Welcome to the Quickstart Problem-Solving Training and Exercise, Part 3, the 4 types of problems. This is a review version, the first release. If you watch this, I would very much appreciate your comments. What did you like? What would you like to see improved? As with anything, this can always be improved, especially with feedback by those who are using it. Here's the email address to send your comments. Thank you. So why do we need a fresh way of looking at problem solving? Let me address that question with the old parable of 4 blind people who encounter an elephant, each taking hold of a different part and describing it as a snake, a tree, a wall, and a rope. They're all right, sort of, but it's not an elephant. The same is true, I believe, for many of us in how we understand and approach problem solving. Lean practice has, for years, emphasized problem solving as a core discipline, but in my opinion, it has often taken a limited view that is not fully able to address the rapid changes we're living with today. According to Lean thinkers, a process, product, or service is defined by standards, how close performance is to the standard, and how the standard should be improved. While this suggests operational excellence, doing things well, it can be a little resistant to doing new things in new ways. This is not an entirely accurate characterization, but close enough for now. And as you'll soon see, this is not a black and white issue. But what about situations where there is no standard, no precedent, where we're doing entirely new things we could not have conceived of a short time ago? In a VUCA world, which stands for volatility, uncertainty, complexity, and ambiguity, the term new normal has become part of the daily vocabulary. But when there's a new normal emerging every day, what's the meaning of normal anyway? All I can say is get used to it. Learn to deal with it. And that's what part 2 is about. Our future may depend on our capability in this area. So in this session, I'm going to introduce a model called the Cynefin sense-making framework. Cynefin is an old Welsh word that suggests familiarity, a sense of orientation, of having your feet planted firmly on the ground. Cynefin emerged in 1999 from the organizational design and knowledge management discipline. Let's take a look at how Cynefin works. The key dimension of VUCA we'll consider when approaching problem solving is the degree of uncertainty of each problem. On the one end of the uncertainty continuum are ordered situations which rely on deterministic standards, best or at least good practices that are consistent, repeatable, learnable, and scalable. But one would also hope that such practices aren't too rigid, but adaptable to change when the right conditions exist. On the other end are highly uncertain, often new situations which have many unknowns, variables, risks, and subjective considerations. Starting out under these conditions is often called the fuzzy front end, since you need to sort things out as you go. They're emergent. Plans are nothing more than targets and hypotheses waiting to be tested against reality. Here's your first look at the Cynefin model, which contains 4 problem contexts. On the right side are simple and complicated contexts, which are relatively certain and prescriptive. In other words, uncertainty is low. On the left side are complex and chaotic contexts, which are far more uncertain. Now let's take a walk through each of these problem contexts to understand how this model works and how we can use it. Let's start with simple contexts, which are ordered, known, and deterministic, where strict adherence to a formula produces the same result each time. Such situations should be approached with a standardized best practice. Baking a cake is a good example. When working inside a simple situation, you must categorize. What type of cake are we making? Where is the recipe? The proper approach is to sense, categorize, and respond. To first categorize the situation into a known solution to be implemented, unless something about the situation has changed and a new standard must be set. Complicated contexts are ordered, knowable, and deterministic. There are known unknowns, like sending a rocket to the moon, which is mostly science, but there are many variables and many things that can go wrong. Complicated contexts are based on standards, universal physical properties, formulas, approaches, and things known to work. They're just complicated, not simple. A simpler example in a space launch with fewer variables and less complications, risk, and precision would be baking a new kind of cake, combining 3 recipes from different kinds of cakes. In that case, you might want to do a little reading on baking technique so it doesn't come out of the oven like a brick. And you might want to analyze some variables like what special materials and techniques must you use? Do you have them on hand? Are they fresh? What's the humidity in your kitchen? How accurate is your oven temperature? Since there are so many variables to be considered in a complex situation, the proper approach is to sense, analyze, and respond. To explore the situation in a scientific manner, to understand the variables and their cause and effect relationships, developing and testing hypotheses before moving forward with a solution. Because there's not always one best solution to be found among the potential variables and solutions, we often speak in terms of good practices rather than best practices. This is typically the domain of experts and expert knowledge, requiring more in-depth training, problem solving, and mentoring to develop mastery. When a complicated context presents a high degree of risk, where health and safety are concerned, for example, or subject to significant regulations, it requires special attention. An example would be the production of a critical medical device. This is where Six Sigma precision may apply. In this case, the standard work is usually taken as fairly strict rules, and you don't deviate from them unless extraordinary conditions occur. Then you're likely to bring in sophisticated analytical tools and methods to sort out the situation and determine the right course of action. Under less rigorous or risky conditions that are still complicated, like baking a new kind of cake, far less precision may be needed, and there may be more fluidity in how standards are applied. Instead of strict, precise rules, we may speak in terms of heuristics, loosely defined guidelines, and it depends on a person's judgment to make the right decisions in each situation. Now let's move to the left side into the uncertainty zone, where you find complex contexts. These can also be very complicated, but they're very dynamic and often don't follow specific physical laws or rules, and they sometimes defy ordinary logic and rationality. Raising a child is a good example of a complex situation. You can read all the books you want, but each child makes you figure it out step by step. Systems involving business organizations or other human-influenced situations are usually complex. Not only do they follow natural laws and rules of logic, sometimes, but they're also subject to human emotions, biases, opinions, agendas, and so on. Neil deGrasse Tyson, the popular scientist and author, admits that such human problems are far more intimidating for scientists to grasp than many complicated challenges in physics. In complex contexts, expertise is necessary but not sufficient. Expertise can actually get in the way due to a false sense of confidence and certainty. Humility combined with expertise is the key here. Ask why and earnestly seek to understand using the scientific method. With complex situations, patterns are emergent, which means we learn about them as they evolve or as we explore them. We usually understand cause and effect only in retrospect, but using a past example as a prescriptive model for responding to future change events is not always appropriate because the system is not deterministic and it may behave slightly differently each time. Attempting to control a complex situation often influences the behavior of the system. It can cleverly avoid intervention and the problem can reappear in a new form. The proper approach is to probe, sense, and respond, to experiment, testing the behavior of the system to understand cause and effect and to determine the appropriate response. It's also important to break the complex problem into pieces that can be explored separately because trying to digest it in one bite is impossible. And mixing too many variables in a single experiment violates the scientific method. You must isolate key variables and solve them independently. If your experiment contains too many variables, unless you have extremely sophisticated analytical tools, all you end up with is a hot mess. And remember, complex systems are dynamic, so what addresses the situation today may not work tomorrow. Therefore, continuous monitoring is required to sustain performance. Finally, there are chaotic contexts, the highest degree of uncertainty. In such extremely unpredictable contexts, there are seldom right answers and many decisions to be made, often in situations of high stress and imminent danger. Being a first responder to a natural disaster like an earthquake, hurricane, or unknown disease outbreak are all good examples of chaotic situations. The proper approach here is to stabilize the situation, taking immediate controlling action to establish some sense of order. Act, sense, and respond. You must act quickly, making decisions and taking swift action with insufficient information. In an emergency room setting, this is called triage. First, check the patient's vitals. Are they breathing? Is the heart beating? Stop the bleeding. Stabilize the patient. Then, once you've shifted them from a chaotic to a complex state, then you can start trying to bring them back to health. Our recent COVID experience is an example of chaotic problem solving on a global scale. As the pandemic unfolded, the spread of the disease and the number of deaths suddenly accelerated in ways we didn't completely understand. We continuously gathered new information any way we could, but in the early stages we had very little. So the scientific community acted, making many recommendations, such as hand washing and surface cleaning, that later proved unnecessary in many conditions, as we learned the disease was airborne. But in the absence of information, we had to do things that seemed appropriate to stabilize the situation, far better than doing nothing at all. While some people have complained that scientists gave erroneous guidance and seem to change their minds often, this is the way the scientific method works, especially in conditions of high uncertainty. Now let's explore progression and evolution of problems. There's a natural pattern to move clockwise as you stabilize and continuously improve. As a chaotic situation is brought to some kind of manageable order by swift, decisive action, it is then chunked up into many complex problems to be solved. Over time, some of these complex problems may be chunked up further into complicated and simpler problems. Often this initial triage decision is made by someone with expertise or authority, since there's high risk. Once the situation is stabilized, control should be returned to the team. However, often there is a risk that leadership may remain in the crisis command and control mode too long before shifting to team experimentation and learning. In some cases, leaders may just get carried away or distracted with the many details. In other cases, perhaps it's their natural tendency to not give up control once they have it. In any case, even when leaders consciously try to stop the controlling attitudes and behaviors and shift back to ordinary practices, many of the interventions persist as new quality control, safety, governance, or compliance policies, procedures, processes, and mindsets. New controls or checkpoints, extra steps, boxes to check, additional approvals, or people may just overreact as if they're required to out of fear as knee-jerk reactions to prevent the really bad thing from happening again. These are like echoes that accumulate over time in the formal and informal management systems, what I like to call process scar tissue. The paradox here is that these efforts are self-defeating. We learned in the value stream flow training session that end-of-pipe controls and compliance steps usually make the process slower and less responsive, more difficult to teach, learn, and perform properly, more fragile, and resistant to change and improvement. You might as well pour a bottle of glue into the process. These extra steps get in the way of the team who should try to solve the problems for themselves in a more sensible and sustainable way. Leadership and management should be especially mindful to loosen their grip and don't leave control and compliance residue behind so rigor mortis doesn't set in. They may consider leaving some low overhead monitoring in place to alert them if the problem reappears. A key to a successful handoff is for the team to conduct a retrospective with a root cause analysis to understand what happened so they can make it more stable and resilient in the future. Let's explore the stabilization step a bit more. As we learned in the Fundamentals of Value Stream Flow session, if processes are not continuously improved, they have a tendency to drift and decay. There's a variety of possible reasons for this natural entropy, including the accumulation of scar tissue from past injuries and interventions. As we just learned, stabilization is the first step when confronting a chaotic situation, triaging the chaos, transforming the situation into manageable complexity, removing the randomness and chaos and creating a stable baseline to move forward from. And for the same reason, it's usually the first step when you're getting started on your continuous improvement journey. Why? In terms of the Cuneiform model, even when the process should be simple or complicated, standardized and in control, it might be done differently by each person, each day, and each location. There might be differing opinions on how it should be done, or the process may just be plain broken. Most organizations decide to commit to continuous improvement only when the pain becomes too great. In Six Sigma terminology, we say the measurable process capability is low. It's unreliable, unstable, inefficient, and unable to produce quality, consistent outcomes. Much of people's time is spent on what we call failure demand, wasting more and more of their time and energy chasing and correcting preventable problems, which leaves less time for the daily work and even less time for improving how they do the daily work. Trying to improve a process under these conditions is like changing the tires on a car while it's driving on a busy highway. Mary Poppendick, one of the early pioneers of the Agile movement, once told me, "The first rule of holes is to stop digging." The first thing the team should do when beginning the improvement process is to quickly stabilize the situation. This is triage, the act step in a chaotic situation. The stable starting point may not be very good, but it's a place to start. Now here's a word of caution to leaders and managers intent on launching a continuous improvement program with a bang by hiring consultants to do the initial kickstart. The start of the continuous improvement journey is the worst time to bring in consultants to do it to or for them. This usually causes fear and frustration. People may be worried about losing their jobs, and it certainly harms the sense of autonomy and trust you should nurture with the team. Most importantly, the team must own the process going forward, and so they must be involved in the stabilization and problem-solving journey. Yes, it does take longer to develop these capabilities internally, but it sticks. The tortoise ultimately wins. That's the nature of deep experiential learning. Once the team stabilizes the situation, they can visualize the process, mapping it, measuring it, isolating the problem areas, establishing consensus on the best way for everyone to do them until they're improved later. This consensus becomes the new initial standard, the baseline upon which continuous improvement begins and is measured against. Now let's put the Q-Niven framework into the general context of lean and agile practice. You may recall in my very first introduction to lean and agile session, I characterized the fundamental difference between lean and agile like this. Generally, lean is about continuously improving, and agile is about continuously innovating. This is not entirely true, however. The origins of lean go back to Toyota, who developed new ways of thinking, which led to sophisticated operational excellence methods that eventually transformed the auto industry. This is what most people think lean is all about. But Toyota also reinvented how autos were designed and developed, much faster, more responsive to changing customer preferences, building variety and quality into the fundamental design. Toyota's product design process laid many foundations for today's agile methods. One notable characteristic of change in the agile world is clock speed. Change in the digital world is much faster than the physical world, and there are frequent disruptions as companies and products make generational leaps forward. Agile tools and methods have evolved to deal with these conditions. Now that I brought up the distinction between lean and agile practice, I'm going to stick with the understanding that lean focuses on standards. Is this really a problem? This is where things start to get really interesting, and we may discover a few paradoxes along the way. Let's look more closely into the simple and complicated domains, deterministic standards where lean is grounded. Now here's some potential confusion I'm going to introduce. A book from the lean world called 4 Types of Problems. Just to be clear, this book is not about the Q-Niven model of the 4 types of problem contexts. The 4 types of problems in this book are based on standards and types of deviations from them, which places them in the simple and complicated problem contexts. Type 1 problems deal with reactive troubleshooting, resolving immediate problems and preventing harm, but not addressing the root causes. This is the stabilization step. Type 2 problems require you to find and fix the root cause of the deviation from standard to return the process to a stable condition, which means closing the gap between the target standard and the actual performance. Type 3 problems require setting new targets to guide a stable process to the next level of performance. While this is essentially innovation, it too relies on defining the next standard to reach for, but it's still framed as improvement from the baseline of the current standard. Finally, Type 4 problems point to creative actions beyond the boundaries of what is known to be possible. Stop and think about this last one for a moment. What happens here? The problem suddenly shifts to the left side. More uncertainty. Precedents and standards don't apply. We've moved into a complex or even a chaotic state where we have to reimagine where we're headed. But from this book's perspective, the process itself remains grounded in standards. So we want to keep the process and the product or service it produces in a complicated delivery mode. These are not black and white boundaries. There's a lot of gray area here, and there's more to be learned as we follow this train of thought. Here's a summary of the 4 types of standards-based problems. I'll give you a moment to review this. And here's a learning link to a 1-hour video where the author, Art Smalley, goes into much more depth. According to this lean-oriented model, Type 4 problems lead to creative actions beyond the boundaries of what is known to be possible, beyond current standards. This is an area where, in my opinion, lean practice doesn't emphasize enough in many cases. So during part 4 of this session, as we walk through the A3 problem-solving exercise, practicing various problem-solving methods along the way, I'll call attention to exactly where the popular A3 template breaks down and where more is needed, in my opinion. This isn't a serious issue since there are many tools and methods that are ready to help here. As we move deeper into the zone of uncertainty, we turn more towards various practices, many outside the lean domain. When we make this shift, the standardized work is no longer the work content, but how the problem-solving and learning process is done in a rapid, rigorous, and repeatable way. The standard work is now the problem-solving method itself. And there are many mature practices to help us. These include Lean Startup. Despite the name, it's more agile than lean. Lean Product and Process Development, which is an elaboration on Toyota's methods. Design for Six Sigma, which moves Six Sigma methods into the design phase of the product lifecycle. Design Thinking, popularized by IDEO, a legendary design firm in the heart of Silicon Valley. And the agile practices of Kanban and Scrum. During part 4, I'll provide an overview of Lean Startup and Scrum. And there's already a Kanban Quickstart exercise available now on the website. Now let's explore what may seem like a paradox. How can we use standards in uncertain situations? As I warned you, there's a lot of gray area here. People who respond to emergency situations, like firefighters, emergency medical technicians, search and rescue specialists, and airline pilots, have standard procedures that they practice over and over until they become habits, so they can respond quickly and safely. And by creating these habits in muscle memory, they're able to put their cognitive energy into addressing the unique, urgent, and often life-threatening needs of the situation. During a recent interview with Jeffrey Liker, author of the popular Toyota Way book series, we spoke about how NGOs can apply lean practice in difficult and often dangerous situations, like first response to a natural disaster or delivering aid in an active war zone. Jeff described what, in organizational design, is called buffering the core. According to Jeff, they must clearly define their core processes and figure out how to create a protective buffer around them so they're relatively untouched by disruptions. In other words, whatever they do regularly, they try to create a stable, consistent process for it and protect it so they can turn their attention to sudden disruptions. This is exactly what first responders do. During part 2 of this video, I mentioned a book, The Checklist Manifesto by Dr. Atul Gawande, the Harvard neurosurgeon that applied lessons learned from airline safety to improving healthcare safety. He points to the countless hours pilots spend in flight simulators learning and using checklists kept within quick reach in each cockpit, specific to each airplane and to each problem. A key point Gawande makes is that while there may be a checklist of over 100 items a pilot should do with a particular airplane in a particular situation, there are usually just a few critical things that must be done to avoid catastrophe. Here's a good example. On January 9th, 2009, as Flight 1549 was climbing out of LaGuardia Airport, the Airbus A320 struck a flock of birds, and both engines failed, while at a dangerously low altitude over one of the most densely populated areas on the east coast of the United States. I'm not going to tell you what Captain Sullenberger did. Just listen carefully for the next 2 minutes. This is an unedited recording, and this is how fast it happened.
Turn left saying 270.
This is Cactus 1539. It's birds. You've lost thrust on both engines. Returning back towards LaGuardia.
Okay, you need to return to LaGuardia. Turn left heading up 220.
220.
Tower, stop your departure. It's got emergency returning. It's 1529. He bird strike. He lost all engine. He lost the thrust in the engines. He's returning immediately.
Cactus 1529. Which engines?
He lost thrust in both engines, he said.
Got it.
Cactus 1529. We can get it for you. Do you want to try to land 1913?
We're unable. We may end up in the Hudson.
Johnny 2760. Turn left 070.
070. Johnny 2760.
All right, Cactus 1549. It's going to be left traffic to runway 31.
Unable.
Okay, what do you need to land? Cactus 1549. Runway 4 is available if you want to make left traffic to runway 4.
ADF, should we make any runway? What's over to our right? Anything in New Jersey? Maybe Teterboro?
Okay, yeah, off your right side is Teterboro Airport. Do you want to try to go to Teterboro?
Yes.
Teterboro, Empire. Actually, LaGuardia departure guy, emergency inbound.
Hey, got it.
Cactus 1529 over the George Washington Bridge. Let's go to the airport right now.
Let's go to our airport. Check. Does he need assistance?
Yes, it was a bird strike. Can I get him in for runway 1?
Runway 1, that's good.
Cactus 1529, turn right 280. You can land runway 1 at Teterboro.
We can't do it.
Okay, which runway would you like at Teterboro?
We're going to be in the Hudson.
The last thing you just heard was Captain Sullenberger saying, "We're going to be in the Hudson." By that time, he was landing in the river. He had just enough time for the few things he had to do. One of those things was to close an air outflow vent near the rear of the aircraft, a design unique to the A320. If he had not closed this vent, the aircraft would have immediately sunk. Because of his training, he could ignore all of the things that didn't matter and focus on what mattered most, which was changing by the second. Practice, mastery of your craft, helps you do the few right things you must do in a chaotic situation, and these can be standardized and learned and become habit. What I first introduced as a paradox looks a little different now that we've established that there are standards needed in highly complex and chaotic situations to keep us out of deep trouble. The way you do the basic work, like landing an airplane or setting up a field hospital 2 days after an earthquake, is highly routinized and practiced until it becomes habit. In the complex and often chaotic process of raising a child, you can read all the books you want to get the basic moves. There are certain core things you should and should not do, or let the child do by themselves. That's the standard work content. But many of the critical choices you and the child face over the years are unique and unscripted. It's at this time that rigorous attention to a consistent and repeatable way for how you solve the problem becomes important. Most parents know that the argument, "because I said so," is not the way to raise a child, at least a well-balanced one. Ideally, as a parent, you should slow down, take a deep breath, and say, "Let's figure this out together," and help them understand the decisions and trade-offs they should learn how to make as they understand the situation, consider their options, and develop critical thinking. That's easier said than done, of course, which is why good parenting is one of the hardest jobs there is. Problem solving, especially in the complex and chaotic domains, is a disciplined scientific process while surrounded by chaos. With the scientific method, we don't just haphazardly or randomly throw things against a wall to see what sticks. And I've already mentioned a number of such rigorous practices, like Scrum, that can help us. Now that we understand the foundations of the Cuneiform model, let's take a brief side trip and take a fresh look at a topic that's on our minds a lot these days, AI and automation. You're welcome to choose your version of the future of automation, scary or helpful. It's likely going to be a bit of both. From a worker's point of view, though, it's clear that automation has changed and will continue to change the nature of work and the way we all earn a living. Many of the simple tasks have already been automated, and if you look at the long stretch of technology development, in many ways it has been very beneficial for humanity. You may have heard the term the Fourth Industrial Revolution, which was introduced in 2016, and if you haven't heard it, you may find this very helpful. You could argue that the first revolution in early humanity were things like fire, simple stone tools, and language. We're not counting those. The first technology-driven industrial revolution was water and steam power, which helped launch the Industrial Revolution that led to many modes of transportation. Humans used to expend tremendous time and energy on these tasks. I suspect most of us wouldn't want to go back there. The second was electricity. I suspect few of us would want to take away electricity either. Then computers emerged, starting in the 1950s. The capabilities these brought, just to healthcare alone, would be difficult to give up. And if you watch a crowd of people, most staring at their smartphones these days, it would be difficult to take those away, though you might argue it might be better for all of us. So the first three technology revolutions arguably cannot and shouldn't be reversed. The net benefit to humanity has been far greater. Although climate scientists would rightly suggest that if you measured the externality costs of burning fossil fuels, we would question many of the choices we made in the last 100 years. Hopefully we'll get better at those choices, and quickly. But now there's the fourth. Emerging technologies that are moving so quickly they seem to be outrunning our ability to make mindful choices. Think about the changes we've seen recently. One example is in banking. Over the past 10 years, with massive investments in digitization and automation, the number of humans involved has been dramatically reduced, in many cases by over 70%. When's the last time you stood at a teller window of a bank? Is this good? Is this bad? Well, it's certainly bad for the people who found themselves needing to find new employment, but as in most things, it's not completely black and white. Then there are many dull, repetitive, and sometimes hazardous things that automation can do that humans wouldn't want to or shouldn't have to do. Consider using robotic automation for hazardous underground mining. How is this not a good thing? Well, you'd have to ask the displaced populations around the world who depend on this dangerous work to feed their families. As anyone in the NGO world knows, good and bad depends on how we approach each situation based on our values. I think most of us can agree that the ultimate goals for AI and automation should not be increasing shareholder wealth or increasing the power of one's nation state over another. From an NGO's perspective, let's agree our goal is to make things better for as many people as possible on this planet. With that understanding in place, let's take a fresh look at the possible progression of automation, aided by machine learning, and whatever AI technologies may come after that. I expect these unforeseeable advances will continue to handle more and more complicated and complex situations. Years ago, we called primitive forms of this expert systems, and that seems to be where we're going. If we're going to harness these emerging technologies to our benefit to make the right value-based decisions, we need to find a way to understand them better, and the Cuneiform model helps us to do that. Here's a chart from a study published in 2017, now 6 years ago, that predicted where this trend was likely to go. So far, their predictions seem pretty accurate. By the way, take note the bottom of this image, showing a continuum from simple to complex, the essence of the Cuneiform model. Few would argue the advantages of automation enhanced by machine learning in healthcare. Computers can now learn from a virtually unlimited supply of recorded images and medical records stored in enormous databases that are growing by the day, reading x-rays and other diagnostics not just faster and cheaper, but spotting potential problems that humans would be likely to miss. How long will it be before they recommend treatment options? Well, that's happening now in many areas of medicine, basing these suggestions on volumes of data. And how long until they can customize those options to specific individuals? I suspect it's only a matter of time. So in virtually any area of human endeavor, AI and automation are likely to be disruptive in the coming years, even to experts. And these technologies will likely soon become accessible and affordable to even smaller nonprofit organizations, especially with efforts from the Gates Foundation and others to make the raw material of global data available to address the challenges of humanity. So the question for each NGO may be, how much do we focus attention on this future? And how much do we focus attention on the front lines, helping people live better, more productive, richer, safer lives by doing things themselves with their own hands? I'm not suggesting there's a right answer, but that you need to think this through carefully in each situation. Hopefully understanding the Cuneiform model helps you think in a new way about this. With that in mind, let's think this life cycle through once more to extract some final wisdom we might be able to use. As we now understand, when starting out, many things are likely to be in a complex or chaotic state. So we try to move them clockwise toward consistency, repeatability, and scalability. But in a world of VUCA, a stable condition may suddenly change, or a sudden external disruption may appear and the innovation improvement cycle starts again. And that's okay. Remember, we grow and develop by embracing problems. There is no finish line, just a steady progression into an unknown future, guided by our values and enabled by our constant striving to make things better. The senior leadership of most organizations is focused on the long-term strategic horizon, which is by definition highly uncertain. They spend much of their time peering into the potentially chaotic future scenarios, trying to anticipate and prepare for them. Generally speaking, the closer we get to the current time horizon, uncertainty decreases as we simplify and develop standard work methods. This puts more focus on frontline workers dealing with standards and a higher degree of certainty. However, and here's one more paradox, those on the front lines are often the first to sense a sudden change in customer behavior, a new competitive threat, or an environmental condition that disrupts our thoughtfully crafted strategic plan. As the professional boxer Mike Tyson once said, everyone has a plan until they get punched in the face. We often call the front lines the canary in the coal mine because they're the first to sense when something is wrong, especially when they have visual indicators on key process points. So everyone in the organization must be comfortable with spotting and addressing problems of all types, from simple to chaotic, and we all must be skillful at managing in such unpredictability. Often our best ideas come from the front lines. We just have to go see and listen to them. So the overall management systems, collaboration, and communication behaviors must create a fast and continuous sense and response feedback loop so the organization can quickly pivot when needed. We covered this theme in Part 2, Organizational Context, and in Part 4, we'll explore various problem-solving tools and methods to make it happen. So as we close part 3, let's bring part 4 into perspective. I'll wrap this up with an illustration. No one problem-solving method is entirely focused on a particular problem domain within the Unified framework. Perhaps you already know about the 5 whys method. When confronting a problem for the first time, a useful technique is to ask why again and again to help uncover causes, getting to the root. Each time the responder answers with the cause that's on their mind, you ask, what is the cause of that? Again and again, it can be both frustrating and very eye-opening, and it can be a simple and effective way when done properly and respectfully. But the 5 why tools method is naturally quite limited. Complicated and complex problems can look like a tree. Effects or symptoms are like the many branches, and the number of potential causes can be quite large, like the root system. 5 whys takes a linear deep dive, boring a vertical tunnel, resulting in a series of one-dimensional causality. But under the surface, the many potential causes are like a complex root system of the tree, and like countless billiard balls, they often bounce around, impacting each other. If we need a better understanding of causality, we need a better tool. The fishbone method, for example, identifies multiple potential causes relating to a problem. And causal loop analysis even shows the dynamic interactions of many causes and effects together. Both of these methods are explored in part 3. On the other hand, while 5 whys is simple and linear and skips many potential causes, when you're just getting started, it might still be the best thing to do first. Let me put this into the Unified model to explain what I mean. In a simple situation, 5 whys may lead directly to the cause. In a complicated situation, it may be a good start to help the team sort out the problem and prepare for a more rigorous analysis, such as using a fishbone. In a complex scenario, it may also be a good icebreaker in a very fuzzy situation, leading to a fishbone, more rigorous data analysis, or another approach. And in a chaotic situation, it may be a series of questions you ask once you've isolated a particular problem, as you're trying to triage a really bad situation to take immediate steps. Or consider this. You might have a team in a room use 5 whys over and over and over to stimulate a sticky storming session. Using 5 whys as the stimulant, get as many potential causes and scenarios on paper using sticky notes as quickly as possible. So here's the final paradox I'll share in this session. Even simple approaches like 5 whys and sticky storming can be effective in chaotic situations if you're skillful in handling them. So that's where we're going next. Congratulations, you've finished part 3. Now we're ready to move to part 4, the hands-on problem-solving exercises. I'll see you there.